Alright, so today we're going to talk about solving trigonometric equations. Now, the part you're solving for is the x, the theta, the beta, the whatever they put there. I mean, you could put a question mark there, and that's what you'd be solving for. So you're actually trying to find an angle that you can plug in right here that satisfies this equation. Alright? So we're going to work these just like you would any other equation. So first, what you want to do is you want to get your, what I would call your variable, okay, which is the sine x in this case. You want to get that together. So I'm actually going to subtract sine x so that I can put it with this one over here. Now, I could easily add this one, but then I'd have a 0 over here, and it would give me a whole extra step. So my first goal is to get my variable together. So now I have a square root of 2 left over here, and a negative sine x and another negative sine x add together to make negative 2 sine x. Now again, you're trying to get this part by itself, all right, the sine x. So since I'm multiplying sine x by negative 2, I'm going to go ahead and divide by negative 2. So now I have sine x is equal to negative square root of 2 over 2. Now, we have done this part before where you're trying to figure out the sine of what angle is equal to negative square root of 2 over 2. So remember, to solve for x, you have to do the sine inverse of both sides. So I'm only going to write this on one problem, just so that it's there. The rest of the time, we'll just assume that you did this to both sides. So if we take the inverse sine of sine, that cancels. So I'm looking for the angle whose sine is negative square root of 2 over 2. So I'm going to look at my unit circle. Remember, your sine is the y value. So if you're looking at your y values, it's none of these, none of these. But right here, negative square root of 2 over 2, that would be at 5 pi over 4. And also at 7 pi over 4. Now remember, the unit circle just keeps repeating itself, right? So if I'm here, if I went around again, I would be at another angle whose sine is negative square root of 2 over 2. If I went around again, that would be another angle whose sine is negative square root of 2 over 2. If I went over again from this spot, same thing with this spot. So we actually have to make sure that we state that. So in our answer, we'll say 5 pi over 4. So x is equal to 5 pi over 4. And then we're going to say plus 2n pi. That means I can take my 2 pi and go around one time. Or if I plug 2 times in here, that'd be 4 pi around, 6 pi around, 8 pi around. It doesn't matter. Okay? So 2n pi. And x is also equal to the 7 pi over 4 plus 2n pi. All right, so on number 2, I'm trying to get tangent x by itself. So I have to get rid of this 3 that I'm multiplying by, and then I'll also have to get rid of the squared as well. So first, I'm going to take care of the 3. I'm going to divide by 3. So that gives me tangent squared x is equal to 1/3. And then I'm going to take care of that squared up there by taking the square root. Now, just like with anything else, if I square root in an equation, I have to do the positive and the negative root. So now I have tangent of x is equal to, and then I'm going to have to simplify this. So really this is the square root of 1 over the square root of 3, right? Which is 1 over the square root of 3. But if I rationalize that, that would be the square root of 3 over 3. So I have plus or minus the square root of 3 over 3. And then I have to take the inverse because I'm looking for what angle has a tangent of this, right? So this is x equals tan inverse of plus and minus the square root of 3 over 3. So I am looking for an angle that has a tangent value of square root of 3 over 3, and I'm looking for angles with the square that has a tangent of this negative square root of 3 over 3. So if you go to your unit circle, all right, remember if you've written these down on your unit circle before, all right, that means that this angle has a this is square root of 3 over 3, right? If I take the y and I divide it by the x, that's square root of 3 over 3. This would be negative square root of 3 over 3. All right, this one would be square root of 3 over 3, and then this one is negative square root of 3 over 3. Those are my tangent values, right? So actually, all four of these angles have a tangent value of either square root of 3 over 3 or negative square root of 3 over 3. So here's the deal. I can actually figure out to go from 30 to 50, how many degrees is that? 30 to 150. It's 120, right? So it's not 120, though, to go from 50 to 210, right? That's only 60. So what I want to do is I want to use this angle, and then by adding pi, that can get me to this angle, right? So if they're on the same line, then I could say I'm just going to add pi every time. And then I could use this angle and add pi to get to this angle, right? And then I would add pi, add pi, add pi, so on and so forth. So I'm going to have two statements, but you always start with the smaller one. Like I wouldn't want to say 7 pi over 6 plus pi because then I would miss the pi over 6, right? So I start with the smaller one. I would take pi over 6 and add n pi, but I would also have 5 pi over 6 and add n pi. So I still have my two statements, but they're not going to be 2 pi because then that would get me missing some things. So I have x is equal to pi over 6 plus n pi, and x is equal to 5 pi over 6 plus n pi. That will get us every single angle that we could come up with where we would have a tangent value of a positive square root of 3 over 3 or a negative square root of 3 over 3. All right, so on number 3, we're trying to get secant x by itself. So I'm going to add 2. So I have secant x is equal to 2. Now, I don't want to mess with all the inverse functions. I want to use just my regular trig functions, sine, cosine, tangent. So I know that secant is the inverse of cosine. So I'm actually going to change this, and then I'm just going to flip what this is. So 2 over 1, I'm going to flip it to 1 over 2. And then I'll do the inverse. So x is equal to cosine inverse of 1/2. So I am looking for all of the angles that have a cosine value of 1/2. So if I pull up my unit circle, that's the x value, right? So pi over 3 has a cosine value of 1/2, and 5 pi over 3. They are not directly across from each other, correct? So I'm going to make two separate statements. I've got pi over 3 plus 2n pi, because I have to make one whole row of evolution to get back to that location. and I'm going to say 5 pi over 3 plus 2n pi. So pi over 3 plus 2n pi, 5 pi over 3 plus 2n pi. So I'm going to get my sine x by itself by subtracting 1. So I have 2 sine x is equal to negative 1. Then I need to divide by the 2. So I have sine x is equal to negative 1/2. And then I'm going to do the inverse so I can get x by itself. So x is equal to the sine inverse of negative 1/2. So I'm looking for angles whose y value, because that's the sine, is negative 1/2. So I look at my unit circle. I know that y is negative underneath. So I've got 7 pi over 6, and then I also have 11 pi over 6. They are not directly across from each other, so I will make two statements, 7 pi over 6 plus 2n pi, and 11 pi over 6 plus 2n pi. So to solve for cotangent, I'm going to add 1. So I have 3 times the cotangent squared of x is equal to 1. I'm going to divide by 3. So I have cotangent squared x is equal to 1 over 3. Then I'm going to take the square root, and we're not going to forget that when we square root, we have to do the positive and negative root of that. So I end up with cotangent of x is equal to plus or minus the square root of 1/3. Now, before I even rationalize this and all that, I just need to realize that I have to flip this, right? So I'm going to do tangent x is equal to plus or minus the square root of 3 over 1. And that actually eliminates having to rationalize, because if I take the square root of these, I get the square root of 3 over the square root of 1, but the square root of 1 is just 1. So I don't even have a denominator anymore. So now I do the inverse. So I have tan inverse of plus or minus the square root of 3. So I'm looking for angles whose tangent is a positive square root of 3 and a negative square root of 3. So I look at my unit circle. We already know that this one was square root of 3 over 3. So this angle is square root of 3. This angle is square root of 3. This angle and this angle, right? This one and this one. Might help if I got the right angles. All right, so I know that this one is directly across from this one. So I will take the smallest, which is the pi over 3. Remember, it's always the one you come to first. So pi over 3 and add n pi. That way I can hit the one that's directly across from it. And then also the 2 pi over 3 and this one. So I can do 2 pi over 3 plus n pi. So pi over 3 plus n pi and 2 pi over 3 plus n pi. On number 6, this one looks a little bit different. But remember, if you have like two factors, like normally, let's say that I had factored something, maybe like this, then I always take this factor and set it equal to 0, right? and this factor and set it equal to 0, and then I work them both out. That's what you're going to do on this one. You already have two factors. So you have cosine 2x is equal to 0, and 2 cosine x plus 1 is equal to 0. So I'm going to start with this one. This one's a little bit different because if you'll notice, there is now a number with your x right here. Like before, it's always just been an x, right? There's been no number with it. So this is what happens. I can't gain access to the 2x until I take care of the cosine, right? So I'm going to go ahead and do the inverse. And when I do the inverse, that's going to leave me with 2x. So I have 2x is equal to the cosine inverse of 0. So the first thing that I need to do is I need to figure out what angles have a cosine value of 0. And then I'll end up taking care of this 2 right here. All right, so on our unit circle, cosine is your x value, so that would be pi over 2 and 3 pi over 2. They are directly across from each other, correct? So I only need to use the pi over 2, and then I can just add n pi. So I've got pi over 2 plus n pi. So 2x is equal to pi over 2 plus n pi. Now, I still am not completely solved for, correct? So I have to take and divide by that 2 that's with my x. So I'm going to divide this by 2, and I'm going to divide this by 2. So I have x is equal to pi over 2 divided by 2 is pi over 4 plus n pi over 2. And that will be my answer for this one. All right, this one is just like what we've been doing, so I'm going to go ahead and subtract the 1. So I have 2 cosine x is equal to negative 1. I'll go ahead and divide by the 2. So I have cosine x is equal to negative 1/2. And then to get to the middle part there, the x, I've got x is equal to cosine inverse of negative 1/2. So I'm looking for all of the angles that have a cosine value of negative 1/2. So that would be the 4 pi over 3 and the 2 pi over 3. They are not directly across from each other, so I have two statements here. I have 2 pi over 3 plus 2n pi, and I also have the 4 pi over 3 plus 2n pi. So x is equal to 2 pi over 3 plus 2n pi, and x is equal to 4 pi over 3 plus 2n pi. Now, sometimes, this one has 3 answers, right? Every now and then, one of these answers will overlap the answer you found here, so you should always look at that. This one starts at pi over 4, right? And then continues around, if you look at what you've said, pi over 2, right? Which is 90 degrees. So if I started here at the pi over 4, and I added 90 degrees, that would get me here, correct? And that doesn't overlap with this angle or this angle, so I don't need to worry about whether I'm overlapping with my answers or not. Number 7, so we're working on getting cosine 3x by itself, right? That way we can then take the inverse. So the first thing I'm going to do is add the 1. So I have 2 cosine 3x is equal to 1. Then I'll divide by the 2. So I have cosine 3x is equal to 1/2. And now before I can divide by the 3, I have to get rid of the cosine. So I have 3x is equal to cosine inverse of 1/2. So I'm looking for all of the angles that have a cosine value of 1/2. That's my x. So that would be pi over 3 and 5 pi over 3. They are not directly across from each other, so I'll make two statements. I have 3x is equal to pi over 3 plus 2n pi. And then I also have the other angle, 5 pi over 3. So 3x is equal to 5 pi over 3 plus 2n pi. And then I'm going to have to solve for x, so I divide everything by 3. So x is equal to pi over 3 divided by 3 is pi over 9 plus 2n pi over 3. Same thing over here. Divide everything by 3. And I have x is equal to 5 pi over 9 plus 2n pi over 3. All right, so on number 8, I have a squared term, a term that's not squared, and then a constant. So I need to factor this like I would a normal trinomial. So I look up front and I see that I have a number in the front, so I need to take it times the back. We'll do the illegal move. So I have sine squared x minus sine x minus 2 equals 0. And then I'm going to factor this like I would any quadratic equation. So I have a minus in the back, which means I have 1 plus and 1 minus. And I know to get sine squared x, I need sine x and sine x. And then what multiplies to make 2 and subtracts to make 1, that would be 2 times 1. And I want that middle term to be a negative. So I'm going to put the 2, which is bigger, with the minus sign, and the 1 with the plus. Now once I get that factored, then remember you have to undo what you did up here. So I'm going to divide both of these by 2. So that's going to give me, pull that 2 up to the front. So 2 sine x plus 1. But this one will actually divide out evenly. So that's going to give me a 1 back here. So now that I have two factors, I'm going to set them both equal to 0. So I have 2 sine x plus 1 is equal to 0. And sine x minus 1 is equal to 0. And now I'll work both of those problems out separately. So I'm going to subtract the 1. And I have 2 sine x is equal to negative 1. And then we'll divide by the 2. So I have sine x is equal to negative 1/2. Solve for x, and I get sine inverse of negative 1/2. So I'm looking for any angle whose sine value is negative 1/2. So if I look at that, sine is my y value, so I'll be looking down here. So 7 pi over 6 and 11 pi over 6. They're not directly across from each other, so we're going to have two statements. X is equal to 7 pi over 6 plus 2n pi. And then x is also equal to 11 pi over 6 plus 2 in pi. I'm not going to circle those yet because we might have an overlap. Okay? So now I'm going to do the same thing here. I'm going to add 1. So I get sine x is equal to 1. And then I'll do the inverse. So sine values of 1. So if I look, that would be my y value. That's pi over 2, and that's it, right? So pi over 2 plus 2 in pi. I don't have any other angles here that have a sine value of 1. So I've got x is equal to pi over 2 plus 2 in pi. And that is not going to repeat with either of these, correct? So that is an answer along with these two. All right, this one is different in the way that we have cotangent and we have cosine, and that's a big problem. But if I see that, then I know that I'm probably going to end up factoring into two different factors that I can set separate. So I'm going to go ahead and I'm going to subtract the 2 cotangent x and get it on the same side as everything else. So I have cotangent x cosine squared x minus 2 cotangent x equals 0. So if you look at this term and this term both have a cotangent x. So I'm going to factor that out. So cotangent x factored out, that would leave me with cosine squared x. And then 2 cotangent x divided by cotangent x is just 2. So now I have a factor that's just cotangent, and I have a factor that has just the cosine. So I'm going to set each of those factors equal to 0. Now remember, we don't like to deal with the cotangent, so we're going to go ahead and change this to tangent and flip this, but what happens when we flip this, we get undefined, yes? Because this is 0 over 1. So this will be 1 over 0, so we're actually going to get undefined, correct? Or if you want to think about it as 1 over 0, that way for purposes of doing like y over x, you can kind of have that in the back of your mind. So we're looking for angles that have a tangent that is undefined, or if we want to think about it as 1 over 0. So that has to be one of the axes, yes? When you take the y and divide it by x, right, 1 divided by 0, that's undefined for tangent. And the one across from it is undefined, right, because the 0 will be on the bottom. So I can do pi over 2 plus n pi, because they are directly across from each other. So pi over 2 plus n pi. And then we're going to work over here, so I'm going to add the 2. So I have cosine squared x is equal to 2. And then I'll square root. So cosine x is equal to, don't forget your positive or negative, square root of 2. All right? So I am looking for angles that have a cosine value of positive or negative square root of 2. So in a previous lesson, we learned that domain and range play a part. So if you're looking at your unit circle, you might be confused because none of your x values are square root of 2, right? Or negative square root of 2. They're negative square root of 2 and over 2, right? On all of these, or square root of 3 over 2, or 1 over 2. All of those numbers are between negative 1 and 1, right? So we stated in a previous lesson that your range, or your outcome, when you find the tangent, sine, or cosine, has to be within a certain range. So if you think about the value of the square root of 2, so the square root of 2 is equal to 1.4, which is bigger than 1, yes? So when you do sine and cosine, if this number right here, which is like the outcome of when you take your cosine or sine of that, is not in between negative 1 and 1, then you don't have a value for that because it's outside of your range. And if you think about it, remember when we graphed sine and cosine, it always went like this, right? So this is actually outside of those boundaries for your range. So you don't have any values for that, so your only answer would be square root of 2, or pi over 2. Also, in your calculator, you can actually kind of check yourself. So let's say, for instance, on the previous problem, we did sine inverse of 1, right? And we're looking for radians. So if I grab my calculator, I want to make sure I'm in radians, so I'm going to go to mode and change that to radians. So if I do sine inverse of, oh, wrong one. If I do sine inverse of 1, okay, it tells me 1.57, which is going to be the pi over 2. All right? That's what we got as an answer, right? Now, it doesn't give you it as pi over 2, right? It gives it to you as a decimal. It also doesn't give you that it keeps going, right? It's just going to give you that one answer. It will always choose one answer to give you. So I can check that. If you plug in cosine inverse of the square root of 2, so sine, oh, it's cosine inverse. So if I plug in cosine inverse of the square root of 2, watch what happens. It gives me an error because there's not an output for that. Okay? So let's say that you're looking on your unit circle and you're like, okay, this number is not on here because it should be on there, right? It's not on here. Check it in your calculator. If it gives you that error, then you know that maybe you were trying too hard and there's really, not an output for that.